In this video we will go over the rules of exponents. First of all, let's just recall what exponents are. For example, 2 to the power of 7 means that we are multiplying 2 by itself 7 times, right? Times 2 times 2 times 2, if I'm not mistaken. 1, 2, 3, 4, 5, 6, 7, right? So 7 times. Okay, so if we generalize this a little bit more, we can arrive at rules of exponents that I'm not going to prove them here, just list them. Okay, so if you have any number a and then positive integers m and m, a to power n times a to power m is equal to a to power n plus m. Okay, so for example, x to power 3 times x to power 7 is equal to x to power 3 plus 7, that's x to the power of 10. Okay, a to power m times a to power negative m, okay, this is equal to a to power n over a to power m. It just comes from a to power, this is just a case of the first rule. So for example, if you have I don't know, x to the power of 4 over x to the power of 7, this is x to the power of 4 minus 7, which is x to the power of negative 3, and then as we know this is 1 over x cubed. Okay, then we have a to power n, the whole thing raised to power m. In this case we multiply the exponents, this is a to power n times m. Okay, so for example, x to the power of 3, the whole thing raised to power 7 is x to power 3 times 7, which is x to power 21. A times b, this product raised to power n is a to power n times b to power n. Okay, the same holds for this ratio. A over b to the power of n is a to the power of n over b to the power of n. Okay, then if a is any non-zero number, be careful, a to power 0 is defined as being 1 as long as a is not 0, as long as a is not 0. Moreover, just keep in mind that 0 to power 0 is undefined. Okay, and this rule here that we used right here, I can just write it out. A to power negative n is equal to a over n to power n, of course, as long as a is different than 0. Again, 0 to power negative n is undefined. Okay, so we can do few examples here. Okay, if we need to simplify the following expression, I don't know, x cubed to the power of 3 over x to the power of 7 times x to the power of 3 minus 3. I don't know. So let's see, what is this? I have x to the power of 3 raised to power 3 is x to the power 9 over x to the power of 7 times x to the power 0, right? 3 minus 3 is 0. x to the power 9 over x to the power 7 is x to the power 9 minus 7. And okay, let's make this slightly more interesting. So let's raise the whole thing to power negative 4. Okay, so this whole ratio is raised to the power negative 4 times, and as we saw, x to the power 0, as long as x is not 0, is equal to 1. Okay, so 9 minus 7 is 2, x squared to the power of negative 4 times 1 is just this expression. And then what happens when we raise an exponent to another exponent? That's x to the power 2 times negative 4. Be careful, times, not 2 minus 4, but 2 times negative 4, which is x to the power negative 8. And this is 1 over x to the power of 8. Okay, so now we're going to go over rational exponents. And the rules for these are that a to power, well, a to power 1 over n is basically the nth root of a, as long as a is any positive integer. And what happens if I bring this to the power of n? Then in that case, a to power n over m is equal to mth root of a to the power of n, or can be treated as mth root of a, the whole thing, the whole expression raised to power n, of course, as long as m is different than 0, and as long as a is positive. Okay, so let's do non-negative, sorry. So let's do few examples here. When I say that a is non-negative, if a is 0, then that puts a restriction on n. If a is 0, then n cannot be 0, because as we said, 0 to the power of 0 is not defined. Okay, so for example, if we have to evaluate square root of 8 to the power of 2 over 3, okay, square root of 8 is, I'm going to use this rule right here, and I will just write it as 8 to the power of 1/2, the whole thing raised to the power of 2 over 3, and then by the basic property of exponents, 8 to the power 1/2 times 2 over 3 is equal to 8 to the power 1/3, right? And you should know how much is that, so I cancel 2 and 2 and get 1/3. The third root of 8 is equal to 2, because 2 times 2 times 2 is equal to 8. Okay, another example, so let's say that this is A, then part B, 8 to the power 7 over 6 over 8 to the power 1/2 is equal to, by the basic properties of exponents, is 8 to the power 7 over 6 minus 1/2. Now I deal with this difference of exponents, so that's 8 to the power, common denominator is 6, right? So 7 minus, in order to bring this 1/2 to express it as a fraction whose denominator is 6, I have to multiply top and bottom by 3, so that's 7 minus 3 over 6. That's 8 to the power of 4 over 6. Simplify this fraction, that's equal to 8 to the power 2 over 3, right? Now there are two ways that you can do this. You can square 8 to get 64 and then find the third root of 64, or simply, as we already know, we can use what we already know, third root of 8, which is 2, so 2 squared is equal to 4, right? Third root of 8 is equal to 2. Okay, so number 3. Let's simplify this expression. X to power 2 over 3 times x to power 5 over 3 over negative x to power 1 over 6, the whole thing raised to the power of 2, and then the whole expression is raised to power negative 1/2. Okay, so let's first deal with the expression in the square brackets. Okay, in the numerator I just have multiplication of exponents, so that's x to the power of 2 over 3 plus 5 over 3, divided by, I have a constant of negative 1 times x to power 1/6, that's negative 1 squared times x to power 1 over 6 squared. I will deal with this exponent at the very end, although that doesn't have to be the case. Of course, you can raise each of these to the power of 1/2, negative 1/2 first of all, which means multiply each of these by negative 1/2. You will get the same answer. So here I have x to the power of 7 over 3 over negative 1 squared is 1, x to power 1 over 6 times 2, that's 2 over 6 to the power of negative 1/2, and this is x to the power of 7 over 3 over x to the power of 1 over 3 to the power of negative 1/2, and then in the parentheses I have 7 over 3 minus 1 over 3, 7 over 3 minus 1 over 3, 6 over 3 to power negative 1/2. You cancel 6 and 3 and you get x squared to the power of negative 1 over 2. Okay, and this is equal to 1 over, is equal to 1 over x squared to power 1/2, which is nothing else but square root of x squared. And now square root of x squared, depending whether x was defined to be positive or negative, right? It's either going to be it's going to be absolute value of x. Square root of x squared is absolute value of x, but be careful, in order the whole expression to make sense, right? So here I have the 6th root of x. That means that x has to be positive, right? So I just get 1 over x. Square root of x squared is 1 over x because x is positive. Why is it positive? In order to make this expression here to make sense. Okay, and let's do one more example. We need to simplify. Square root of x times the cubed root of x squared times the 4th root of x to power negative 3. Okay, this is not very clear, so I'm just going to rewrite the same thing. So square root of x times the cubed root of x squared times the 4th root of x to power negative 3. So this square root here means that I can write it as exponent of 1/2. So this square root here becomes exponent of 1/2 of what? What do we have inside? X times, now the cubed root of this expression that is going to show up here, right? Just the cubed root, I can write it as exponent 1 over 3. And in here I have x squared times x to power negative 3 raised to power 1/4. Once I have expressed the roots as exponents, as rational exponents, this simplification is made way easier because I just follow the rules of exponents, right? So x to power negative 3 raised to power 1/4 is x to power, I multiply negative 3 times 1/4 is negative 3 over 4, the whole thing raised to 1/3, and then at the very end raised to power 1/2. Now I add the exponents of these two exponents, sorry. So that's x times x2 plus negative 3 over 4, that's minus 2 minus 3 over 4. Okay, and that part is raised to power 1/3 to power 1/2. So that's x times 8 minus 3 is 5, so x times 5 over 4 raised to power 1/3, and then raised to power 1/2, which is x times x to power 5 over 12 raised to power 1/2. Okay, this here x means is x to the power of 1. So basically what we have in the brackets is x to power 1 plus 5 over 12 raised to power 1/2. 1 plus 5 over 12 is x to power 17 over 12 raised to power 1/2. And at the end I just have to multiply these two exponents. X to power 17 over 12 times 1/2 is equal to x to power 17 over 24, right? And if you want to express this as a radical, this is going to be the 24th root of x to power 17.